Hi everyone, in this video we'll take some limits of piecewise functions. In part A, we have the function of x equals to x squared minus 25 over x squared plus 6x plus 5 when x less than to negative 5. And the second piece is x plus 5 over 2 when x greater than or equals to negative 5. And you have to find limit of x when x goes to negative 5. Now, since negative 5 is a common between the two intervals, this means you have to find the limit of x equals 5 or negative 5, sorry, from right and from left of negative 5. So you have to find the limit around negative 5. If we have x less than number in general, x less than a, this means a from left. And if we have x greater than number, it means the number from right. So if we have x greater than a, it means a from right. X less than a, it means x, it means a from left. So here we have x less than to negative 5, it means negative 5 from right. And here we have x greater than or equal negative 5, which means negative 5 from right. Here, sorry, we have negative 5 from left because we have x less than negative 5. Now, you have to find limit the function when x goes to negative 5 from right firstly. So we have limit f of x when x goes to negative 5 from right. This is negative 5 from right, and you have to use this function x plus 7 over 2. So we have limit x plus 7 over 2 when x goes to negative 5 from right. Now you have to use direct substitution to find the limit, and it will be negative 5 plus 7 over 2, and this gives us 2 over 2, which is 1. So the limit from the right of negative 5 is 1. Secondly, you have to write the limit of the function of x when x goes to negative 5 from left. And here we talk about this interval, and we will use this function. So this is equals to limit x squared minus 25 divided by x squared plus 6x plus 5 when x goes to negative 5 from left. So this limit you have to use direct substitution, and you have to plug in the value of x equals to negative 5 and the inside function, and you will get 0 over 0. So you have to factor the numerator and denominator to find the limit. So our limit is limit. Now x squared minus 25, it is difference between two squares, and you have to write 25 as 5 squared, and you have to use the formula of the difference between two squares. A squared minus b squared equals to a plus b times a minus b. So we have x plus 5 times x minus 5 divided by, now x squared plus 6x plus 5, it is a quadratic formula or a quadratic expression. So you have to get two numbers, multiply of them equals to 5, and sum of them equals to 6. And these two numbers are 5 and 1, because 5 times 1 is 5 and 5 plus 1 is 6. So we have x plus 5 times x plus 1 when x goes to negative 5 from left. Now you have to eliminate x plus 5 with x plus 5, and you have to plug in the value of negative 5 in the inside function, and you will get negative 5 minus 5 divided by negative 5 plus 1, and this gives us negative 10 over negative 4 divided by 2, the numerator and denominator, and you will get 5 over 2, and as a decimal number it will be 2.5. So limit of the function when x goes to negative 5 from left is 2.5, and equals 1 when x goes to negative 5 from right. So we have different limits around x equals to -5, which means that limit f of x when x goes to -5 does not exist. Now in part B, we have a piecewise function, but we don't have the intervals x less than number or x greater than number. We have x not equals to 1 and x equals to 1. Now x not equals to 1, no need to compute the limit around 1 from right and from left of 1. This is what you have to find, limit g of x when x goes to 1. No need to find the limit when x goes to 1 from right and 1 from left, because not equal means greater than and less than as well. So there is no limit from right and from left when you have a piecewise function has not equal. So directly, if you want to find the limit, you have to find the limit from here. So limit g of x when x goes to 1, this is equal the limit of this function, 5x squared minus 7x plus 2 divided by x squared minus 1 when x goes to 1. Now by direct substitution, if you plug in x equals 1 in the inside function, you will get 0 over 0, which means you have to factor the numerator and denominator. In a numerator, in the top, you have a quadratic expression with leading coefficient not equals to 1. The leading coefficient is 5. So the first step to factor this function, you have to multiply 5 by the constant term, 5 times 2, which is 10, and you have to get two numbers, multiply of them equals 10, and sum of them equals to -7. And these two numbers are -5 and -2. So the limit will be 2 brackets up, and you have to put 5x here and x here because we have 5x squared. This is the term with the highest degree we have in the inside function. Now since we have 5x in the first bracket here, you have to divide one of these two numbers by 5. And you know that -5 is divisible by 5, but -2 is not. So you have to divide by 5 here, and you will get -1. And you have to put -1 in the second bracket, -1. And you have to put -2 in the first one, -2. So this is the factorization of the function at the top. Now go to the denominator and factor x squared minus 1. As you know, 1 we can write it as 1 squared. So we have difference between two squares, and you have to use this formula. So it will be x plus 1 times x minus 1 when x goes to 1. Now you have to factor the numerator and denominator, and you have to cancel the common terms or the common expressions in the top and the bottom. So we have 5x minus 2 over x plus 1. Now you have to plug in x equal 1 inside the function. You will get 5 times 1 minus 2 divided by 1 plus 1, and this gives us 3 over 2, which is 1.5. So the limit exists and equals to 1.5. Here we don't have 1 from right and 1 from left because we have not equal. You have to compute the limit from not equal piece. And this is the end of part B. Now in part C, we have limit h of x equal x cubed minus 8 divided by ax squared minus 4a when x greater than 2. And greater than 2 means 2 from right, and less than or equal means a from left, or sorry, 2 from left. Now if limit h of x when x goes to 2 exists, find the value of a. This is the question. Since 2 is a common x between the two intervals, you have to find limit from right of 2 and from left of 2. Then you have to make them equal, because the limit when x goes to 2 exists. This is information from our question. So firstly, we will find limit h of x when x goes to 2 from right, and you have to use the function here. So we have limit x cubed minus 8 divided by ax squared minus 4a when x goes to 2 from right. If you use direct substitution and plug in the value of x equals 2 in the assigned function, you will get 0 over 0. So you have to factor the numerator and denominator. The numerator is a difference between two cubes, but you have to write 8 as 2 cubed, and you have to use this formula, a minus b multiplied by a squared plus ab plus b squared. So the limit will be limit of a minus b, it will be x minus 2 in our expression, multiplied by a squared, which is x squared, plus ab, which is 2 times x, plus b squared, which is 2 squared, 4, divided by, and denominator we have ax squared minus 4a. So the first thing you have to do is to factor out a from both terms, and you will get x squared minus 4 when x goes to 2 from right. Now what about x squared minus 4? It has difference between two squares, but you have to write 4 as 2 squared. So we have x squared minus 2 squared, which is a squared minus b squared. It will be x plus 2 times x minus 2. So the limit will be x minus 2 times x squared plus 2x plus 4 divided by a multiplied by x plus 2 times x minus 2. Now you have to eliminate the common expressions between the numerator and denominator. So you have to cancel x minus 2 with x minus 2, and you have to substitute x equals 2 and the function inside, and you will get 2 squared, which is 4, plus 2 times 2, 4 again, plus 4 divided by a multiplied by 2 plus 2. So we have 12 over 4a. Now divide up and down by 3, you will get 4 over, divide by 4 up and divide by 4 down, you will get 3 over a. So this says limit h of x when x goes 2 from right. Now you have to find limit h of x when x goes to 2 from left. 2 from left, you have to use this function. So limit h of x when x goes 2 from left, you have to use the second function. So it will be 3 over 2 multiplies by 2. Cancel 2 with 2, you'll get 3. Now since the limit of h of x exists, this means that the limit from right of 2 equals the limit from left of 2. So you have to make them equal, and you will get 3 over a equals to 3. Now we can write 3 as 3 over 1, and you have to do cross multiply. 3 times a is 3a equals 1 times 3 is 3. Then you have to divide both sides by 3 to get the value of a. So a equals 1. So this is the value of a that makes the limit of the given function exist when x goes to 2. And this is the end of part C, and that's it. Thank you.